Okay, I decided to do a another quick video for chapter 4. So again, condensing everything down to just the best method for doing these problems. So everything is based on cross multiplication. Okay, and this is sort of a shortcut for dealing with fractions and proportions. So if it's set up like this is a proportion is always set up like this. Okay, and don't worry that these are letters. These are just placeholders. So these will be numbers. One of them will be an unknown, so an x variable. Okay, it's always set up as a over b equals c over d. And without going into the theory of why this works, cross multiplying meaning you can move these positions across the equal sign and then up or down. So you can move in this pattern, okay, and the proportion still holds. Now, also remembering if you move a letter, then a 1 will take its place. So this could be, let's say this could lead me to say something like if I switch the A and the D, can basically switch places. Okay, or say, again, from the first one here, I can solve this for A just by moving the B. That's the most common one, where you put your unknown in the A position, and then you move the B up and over. So that would lead you to this. A equals B times C over D. Of course, there's a 1 here, but over 1, you don't have to write it. Okay, so that over 1, that position basically goes away. Okay, another shortcut here, if we start with the same positions, okay, first of all, equations in math read the same right to left as left to right, so you can switch the sides. So I can write this, where I've just flipped the sides. Also, you can flip both fractions top to bottom, okay, and it still holds. So I can go B over A equals D over C. Okay, so in essence, as long as you do both at the same time now, not one or the other, you can flip side to side, or you can flip top to bottom, again, both sides. Just strategies for getting your unknown in the upper left position. Okay, now proportions. So this would be where you're given a portion, and I'll just use the gear ratio. So let's say we have a 1:2 gear ratio, and this is number of teeth on small to large. Now a problem would say something like if I have 12 teeth on the small gear, then how many on the large? Okay, so first of all, you have your ratio 1:2. I have one of my variables and I don't know the other one. Okay, so the way I set this up, I've always set it up so that your unknown is on the top in this A position, because that's the fewest number of steps needed to solve for it. Okay, so I'm going to use as a ratio large to small, even though it's given as small to large, large to small. Okay, and this, then the ratio here would actually be 2:1, written like that. Okay, well, small to large would be 1:2, large to small would be 2:1. You just reverse it. Okay, now when I'm setting up my proportion, I'm going to treat the question mark here, that's my x variable. Okay, so I have x, I should have put an x here, x large teeth compared to 12 small teeth, and I'm using large over small, so I'm going to say x over 12 is equal to, and because I'm doing large over small, is equal to 2/1. And as I showed you, it's actually this one right here, where I'm going to take the b and move it up and over. So the 12 moves up and over. So this becomes x equals 12 times 2 over 1, and that's 24. Okay, so again, it doesn't matter what these are, but you're given the ratio in one of the variables here, the 12 in this case, and the unknown, set it up so that the unknown is on top in the ratio. You might have to flip it like we did here, and then you have one move. Okay, and basically this is just this method is just to decide if you're gonna multiply or divide. Okay, in this case we multiply because there's more teeth on the large gear. Okay, and one more thing here, this is how to deal with percents. Remember, percent, again, it's a ratio and a proportion, so all this cross-multiplying stuff still applies. It's just a very specific proportion where you're always taking a ratio out of 100 or compared to 100. So a percent is going to be part out of whole. Okay. That's the ratio. It's always part out of whole. A percent, something like 12%. Because percent means out of 100, then the part out of the whole is going to be 12 over 100. Incidentally, to convert this to decimal, just divide 12 by 100, and that's 0.12. So that's a scale going back and forth. And basically, divide 12 by 100, or in this case, multiply by 100 to go back to the 12. Okay. Now how this looks in a problem. So let's say a problem could be like written out. 6 is what percent of 30? Okay. 6 is what percent? Now in this case it's the percent that's the unknown. That's going to be our x. Okay. And we're always setting up our proportion as part over whole. So if my unknown is the percent, then that would be like x percent would be x over 100. So I'm going to set it up like this. X over 100 equals the part out of the whole. 6 out of 30. In the same step. See, the way we're setting this up, it's always the same step. You multiply this bottom number up and over. So 6 times 100 over 30, and then you just do that in the calculator, and that comes out as 20, and that's a percent. So we can say 6 is 20% of 30. Now the other way would be a question like this. We could say, what, and I'm going to use the same numbers, but it could be any numbers. What is 20% of 30? So you see how that's different? Here we have the percent, but not the smaller, the part number. Here we had the part number, but not the percent. So the part number is the unknown. That's the x. Okay. And so I'm going to switch it around because I always want to put my x in the top left. It's still part over whole. So now on the left I have x over 30. And this equals part over whole of the percent is 20 over 100. And again, same motion, same movement every time. 30 multiplied up and over. So x now is 20 times 30 over 100. And this, we all know the answer should come out as 6. So that comes out as 6. Okay, that's it.